Entropy and creation. Destruction and birth. The universe is a delicate, unrelenting cycle of opposites. But behind the silence of the night sky, there is a relentless, accelerating engine of change. Today, we step back to see the full scope of our existence, from the birth of stars to the decay of information itself. Let's dive into the cosmic clockwork. Most of the time, we find ourselves stuck in a routine. Every day feels like a copy of the last. Nothing seems to happen, nothing seems to change. And honestly, the slice of time and space we each occupy is so incredibly small that when we don't use it well, very little actually happens. At least, that's how it feels from where we're standing. And in a cosmic sense, it almost looks that way too. The sky above us seems like it's been the same sky for thousands of years. The planets, our sun, they've just been there, steady and patient, through all of recorded history. The same stars and planets that show up in ancient stories are still hanging above us tonight. That's not a bad thing, by the way. A more chaotic system wouldn't have us in it at all. But because we're so used to this apparent stillness, we sometimes forget how vast space truly is and just how small our little world is, how little room our entire solar system takes up on a cosmic scale. So lean back for a second, because right now, in this very moment, I want to talk about what's actually happening out there while we've been busy with our own lives. Today we're going to walk through the jaw-dropping, mind-bending cascade of events unfolding across the universe at this exact second. Fair warning though, so much happens in a single second that it might make your head spin. Ready? Let's go. Let's start close to home. Our Earth is currently hurtling through space at 108,000 kilometers per hour along its orbit around the Sun. That works out to roughly 30 kilometers every single second. Before you even finished reading that sentence, Earth had already moved 30 kilometers through the void. But it's not just Earth. Our entire solar system, the Sun, every planet, every moon, every comet is orbiting the center of the Milky Way at 720,000 kilometers per hour. That's 200 kilometers per second. And even that's not the full picture. Our galaxy, along with a cluster of neighboring galaxies we call the local group, is being pulled toward a massive gravitational point in the cosmic web known as the Great Attractor, at 1,000 kilometers per second. Meanwhile, within that local group, the Andromeda galaxy is closing in on us at about 100 kilometers per second. We already know that in roughly 4.5 billion years, Andromeda and the Milky Way will collide and merge into something entirely new. So even if you feel completely still right now just sitting there, we've already traveled thousands of kilometers into our cosmic journey since this piece began. The sun is burning for us every second. While all of that motion is happening, our sun is doing what it's always done, keeping the lights on. And it does this by destroying a little bit of itself every single second through a process called nuclear fusion, where hydrogen atoms are slammed together to form helium. Every second, the sun burns through 600 million tons of hydrogen. The result is 596 million tons of helium. That missing for million tons? That's the energy, the heat and light that makes life on Earth possible. As a side effect of this process, the sun showers us with trillions of cosmic particles every second. We're talking 10,000 to 20,000 cosmic ray particles hitting every square meter of Earth. Without our atmosphere and magnetic field, that radiation would strip our planet bare, leaving it looking a lot like Mars. Under that protective shield, plants produce around 3,000 tons of oxygen every second, and all life on Earth consumes almost exactly the same amount. Meanwhile, 16 million tons of water evaporate every second, and an equivalent amount falls right back down as rain. It's an extraordinary cycle, running continuously, without pause. Stars are being born right now. Let's zoom out to the stars. We tend to think of them as permanent fixtures, ancient, unchanging. But the universe was once a very different place. About 11 billion years ago, the cosmos was putting on a fireworks show unlike anything that exists today. Stars were being born at a staggering rate, an era sometimes called cosmic noon. But eventually, most of the available material got locked up inside those newly formed stars, and the raw ingredients for new ones became scarce. Production slowed dramatically. Today, the rate of star formation across the entire observable universe is only about 3% of what it was at its peak, which still sounds like it might be almost nothing, but let's put it in perspective. Right now, across the full observable universe, 4,000 stars are born every single second. 4,000. That number just grew by 4,000 again and again. And yet, despite that scale, our own Milky Way galaxy produces only about 5 new stars per year. That's how incomprehensibly vast the universe is, 4,000 stars a second across all of existence, and our galaxy barely manages 5 a year. Of course, what's born must eventually end. Stars die too, in all kinds of ways. I prefer to think of it as transformation. They shift into new forms, new structures, sometimes quietly, sometimes in spectacular fashion. The largest ones go out in supernovae, swelling to unimaginable sizes. then collapsing inward, scattering most of their mass across the cosmos in a brilliant explosion. Even now, in this relatively quiet era of the universe when stars like our Sun are in their middle ages, an estimated 3 to 10 supernovae occur every second across the observable universe. So while 4,000 stars are being born every second, only about 10 are dying. The universe, despite everything, is still very much in a period of creation, where physics gets weird. Here's where things get a bit harder to wrap your head around. The universe is expanding. The expansion that began with the Big Bang never stopped in a sense. We're still inside the Big Bang right now. But here's the strange part. You'd expect that expansion to be slowing down. Think about an explosion. The shockwave spreads out, loses energy, and eventually fades. A bomb's effects don't accelerate over time. That would be absurd. And yet, a few billion years ago, something happened. We don't know what, but the expansion of the universe suddenly started speeding up. We call the force behind this dark energy something that seems to emerge from the very fabric of expanding space itself. And because of it, the universe is currently expanding at about 7.2 billion kilometers per hour. Let that land for a second. That's 2 million kilometers per second. The speed of light is 300,000 kilometers per second. The universe is expanding at nearly 7 times the speed of light. But wait, isn't nothing supposed to travel faster than light? Here's the thing, that rule applies to everything inside the universe. The universe itself isn't bound by the laws it contains. Space expanding isn't the same as matter moving. The laws we live by don't constrain the canvas they're written on. And so, even as we're talking, the universe has expanded by millions more kilometers, casually breaking every rule we thought was unbreakable. Ancient light is still passing through you. There's one more thing worth sitting with. About 380,000 years after the Big Bang, the universe cooled enough for light to travel freely for the first time. That light, the oldest light in existence, what we call the cosmic microwave background, is still out there, still moving. And right now, trillions of those ancient photons are passing through your body every second. You are literally bathed in the oldest light in the universe. The glow of the Big Bang is still touching you, but it's not all beautiful. Alongside all of this creation and motion, disorder is growing too. Entropy, the tendency of systems to move toward chaos and irreversibility, is increasing every second. Black holes are a big part of this. When something falls into a black hole, its structure, its history, its information becomes indistinguishable from everything else that fell in. Information is lost, and as information disappears, entropy climbs. There are an estimated 10 squared black holes in the observable universe, and every second, entropy increases by roughly 10 to 10 units. The universe is, moment by moment, losing its memory of itself irreversibly. 10 minutes of everything. Let's bring it back together. We've probably been here about 10 minutes. In that time, here's what actually happened. Earth moved 18,000 kilometers around the Sun. Our solar system traveled 120,000 kilometers through the Milky Way. Our galaxy crept 600,000 kilometers closer to the Great Attractor. Andromeda got 60,000 kilometers closer to us. The Sun converted 360 billion tons of hydrogen into helium. Some 10 squared to the power of 1 cosmic particles slammed into our atmosphere. Plants produced 1.8 million tons of oxygen, all of it consumed. 9.6 billion tons of water evaporated and fell back to Earth. About 2.4 million new stars were born across the universe. Between 1,800 and 6,000 stars completed their lives. Thousands of planets continued forming, and the universe itself expanded by roughly 1.2 billion kilometers. All while you were reading this. And back here, on Earth, while the cosmos was doing all of that, life on our little planet kept spinning too. About 4 or 5 people were born every second. 2 more said goodbye. Hundreds of millions of living things were killed by other living things, death feeding life, as it always has. Somewhere, another species slipped into extinction. We lose an estimated 100 to 200 species every single day. But in the same breath, millions of new genetic mutations occurred, life quietly rewriting itself, preparing for futures we can't imagine. The point of all this, in those moments when life feels flat, when nothing seems to be happening, when everything seems stuck, the universe is anything but still. We think we're standing still. We're traveling thousands of kilometers. We think nothing is changing. Millions of stars are being born. The universe looks silent. It's expanding, vibrating, breaking apart, and rebuilding itself every second. And maybe that's why cosmology, really sitting with the scale and motion of existence, produces such a strange feeling. It makes you feel small and insignificant, yes, but it also hands you something else, a new kind of understanding. We are not separate from this. We are part of it, at every scale. That thought, somehow, makes me feel very calm. Glad you're here. Until next time, take care. If you enjoyed the video, don't forget to like and subscribe. We'd love to hear your thoughts, so feel free to leave a comment. What should our next video be about? Let us know in the comments below.